Okay, this is the second part of the booklet that we'll be looking at. And the first question is a common one where you have a certain length of rope or ribbon or lighting, and you need to work out the maximum area that you can form, or a relationship between the area and the lengths of the sides. So if I have 500 centimeters of ribbon, I can make different sized rectangles, and each rectangle will have a different area, even though the outside perimeter is the same, 500 centimeters. So I've drawn a couple of rectangles there. For example, I could have the length of the rectangle, the maximum length I could have would be 250 centimeters on each side. So I would have 250 centimeters each side, which would give me 0 for the short side of the rectangle. Or I could go up to, let's say, 50. You need to make a table. So let's go up to have the short side A is 50, like I've drawn here. And so that's my short sides of 50. That leaves 100, leaves 200 and 200 that could be my other sides. Okay, what happens if I have 100 on the short sides? 100 each side would be 200, leaving me 300 more centimeters, so it must be 150 on the other longer sides. And that's like the other one I've drawn. I could go up, again, 150 is going to 150 on each side still means 100 on the other sides. And again, I don't need to do too many. That'll be enough. I've done that the wrong way around actually. I meant to keep going. Sorry, I'll go back here. 150. Let's go up to 200 for those sides. That gives me 50, and if I make this side 250, I get back to 0. Okay, so those are combinations of sides. Now the area we multiply. We have to times the length by the width of the rectangle. So I'm going to have 0 area here. 50 times 200 is 10,000. I'm going to squeeze these zeros in. Then I get 15,000 centimeters squared. 15,000, 10,000, and 0. So my graph, it will look like 0, I get, this is my area, is up the side, and this is the length of the rectangle down the bottom. So at side A is 50, I get 10,000. With 100 centimeters side, I get 15,000 area. With 150, I also get 15,000. This is very rough here, I'm sorry. 200, I get an area of 10,000, and back down. So as you can see, we have a parabola. Now it says investigate, so we've done our investigating, we've made a table, and state the relationship. So that means they want an equation of this graph between the area and the length of the side. So we know that our two intersects there are y equals x. Oops, this might be wrong. Y equals x and x minus 250, and that will be a negative because it's sad face upside down. Okay, so there's my equation, and investigate between possible areas. And the next question is, I'll describe the height. Okay, so the maximum, you may want to state what's the maximum area that would be right between 100 and 150. So that would be when the sides are 125 centimetre side, would give you the maximum area for the rectangle. I've got on the next page. What's the effect of increasing the height or the length of the rectangle? So as we increase, we're starting at 0 here, and we're increasing the length of the side as we go across the graph. So the area increases to a maximum area when the length is 125 centimetres. And then the area decreases again down to a maximum side length of 250 centimetres, and the area is 0 again. So that's the effect of the increasing the height. It increases to a maximum and then it decreases again. Now, Morgan is going to have a longer ribbon. So the ribbon is going to be 500 plus y. So the ribbon length is going to be 500 plus an amount. Now I want you to look at the parabola graph here. When we had 500 centimetres of ribbon, this end value was half of that. And the point where the maximum area was half of that again. So if Morgan is using 500 plus y, then my graph is going to be like this. The end point of my graph is going to be half of 500 plus y over 2. Half of that is going to be my maximum point, and the graph's going to go in the parabola shape. And the maximum point, if it follows the way the graph was formed with 500 centimetres, this point halfway is going to be 500 plus y. It's going to be a quarter. The end point here was half of 500 plus y, so this maximum point is going to be a quarter, or divided by 4. 500 plus y over 4 would give us the maximum area. So the next question, sorry, this is somehow chopped off here. Again, they like these questions. We've got a cuboid shape, and they've given you the formula at the top of the page here. So this is our formula for the volume of the cuboid. Now draw a cuboid so that you know what you're looking at. And we're told the cuboid height, here the height of the cuboid is 12 centimetres. And the other two sides add to 15. So this top length, for example, if that's 14, then the side width must be 1. So again, we've got to make a table. In this table, the various widths of my cuboid. 12 stays the same, it's always 12 high. But the length and the width, here I've used 14 and 1, they are going to always be adding up to 15 centimetres. So my volume is my height times my length times my width. So I've done a little table here. If the width is 1, my volume is going to be 12 times 1 times 14. If my width is 5, for example, it'll be 12 times 5 times 10, because 5 and 10 add to 15, which gives me a volume of 600. if x is 10, again I get a volume of 600. And like the previous problem, I can draw that as a graph with this is my x value here, which is the width of the cuboid. So it forms a parabola, and the maximum volume, the question, you sketch a graph of this, which I've kind of done here. It's not very accurate. You can add more numbers in than just using those ones I've chosen. You could have x is 2 centimetres, x is 3 centimetres. You can put a few more values in. So the maximum volume of the tank is when x is at 7.5. You've got the formula up the top of the page, and you need to put 7.5 in there. So I've written that over here. Y equals 12 times 7.5 times 15 minus 7.5, which is 7.5, and that comes out to 675 centimetres cubed, its volume. What is the length of the base, which gives us maximum volume? The base, I presume they're talking about our x, which is 7.5, which would also be the width of the length and the width would both be 7.5. Question here. This is a question about memorizing decimal places of pi. And we are told that Peter could memorize 742 decimal places. Question 1, she started with 6 places on the first day, and every day she doubled the number that she memorized. So I've done a little table, the days going down. On the first day she memorized 6, then she doubled it. So on the second day she memorized 12, the third day she doubled it again. So investigate and state the relationship, so that's make an equation, of the number of decimal places over a 2-week period. Okay, so again we could draw a graph of this. I've lost the graph paper, sorry, but on the graph 1 would be 6, 2 would be 12, 3 would be 24. So investigate means make a table, draw the graph if you can. When it says state the relationship, it usually means to find the equation. Now, when we see these numbers going up, times 2 times 2 times 2, or times 3 times 3, we have to think of exponential graph. So y equals, now I'm going up by timesing by 2, so it's 2 to the power of x. Exponential, it's to the power of x. Does that help you remember? Exponential is to the power of x. But like the other graphs, I have to adjust the beginning of the graph here. Now, if x is 1 here, 2 to the power of 1 is 2, and I've got a 6 there. Okay, so it might be adding 4 each time. Let's try it with the second one. On day 2, x is 2. 2 to the power of 2 is 4, plus 4 would give me y equals 8. But that's not right, because I've got, when x is 2, I've got 12. So maybe we're going to rub that out. How do I get? Another way I could do this would be to times my answer. 2 to the power of 2 is 4, but then if I times 4 by 3, I get 12. Does that work for 1? 2 to the power of 1 is 2, times 3 is 6. Let's try it with 3. 2 to the power of 3, 2 to the power of 3 is 2, 2's are 4, 2's are 8, times 3 is 24. and that's correct. So to state the relationship, I would write y equals 3 times 2 to the power of x as an exponential. Now we've got the equation, we need to answer some questions. How many days did it take to memorize last year's total using this technique? So last year she remembered 742 decimal places. So how many days? So at 7 days she memorized 384, so it must have taken at least 8 days. You can just look that up on your table. The next question. The world record is this many decimal places. So 883,431 decimal places equals 2 to the power of x and times by 3. I want to find x, so I can divide by 3 on this side and divide by 3 on that side. I'm going to work over here. So that leaves me with 27,000, you use your calculator, 810 equals 2 to the power of x. You're going to have to use guess and check a little bit. And I tried 2 to the power of 14 on my calculator, and that was too little, but I tried 2 to the power of 15 equals 32,768. So that gave me, that was how many days? It must be at least 15 days, because 14 days there wasn't enough decimal places. Now the next one, I think I can go on to the next page. Let's see. Okay, on this page, we're up to this part. It has 14 days until the competition. So our x is 14 days, our x is 14 days. She wants to get 2,300 places. So 2,300 equals, we might have an A in here, times, now we're not going to, she doesn't want to double the amount she memorizes every day. She only wants 50% more each day. So each time she's going to times by 1.5 to the power of x. She's going to times the previous number by 1.5 to increase it by 1.5 by 1.5 by 1.5 each time. Now the number up here, the number of days, is 14. So we've got 2,300 equals what number of decimal places? Well, she needs to do it on the first day. I need to work out what this number is in front here. And I know that's 1.5 to the power of 14. And that's 291. So 2300 equals A times 291. That value of A is 230 over 291. So my A value equals approximately 8. So I need to now work out, this was when X was 14 days. I want to know the number of decimal places on the first day, so when X is 1. So now I'm going to use the equation. I know what A is. 2,300 equals 8 times 1.5 to the power of 1, because it's only on the first day. So 1.5 to the power of 1 is, whoops, I don't need 2,300 here. Let me take that out. I'm trying to find Y is how many decimal places. How many decimal places on the first day? So 1.5 times 8 is Y equals 12. So she must learn 12 decimal places on the first day. The next question is an exponential graph, and we're asked to give the equation of the graph. Now when these graphs have been translated, it means that it's been moved down. So I need to look when X equals 1, I put a line as to how far it goes down to the asymptote that runs along the bottom. So that's a 3, so my equation here is Y is 3 to the power of X, and it has moved down. This point here usually goes through Y equals 1. It's moved down 1, so my equation will be Y equals 3 to the power of X minus 1. Now if this is translated 3 units to the right, as with a parabola, the X is going to Y equals 3x, I'm going to put that in brackets. To the right it'll move the opposite to what you think. It'll be minus 3 up there. So I'm moving it right 3, and then I'm moving it 4 units up. So as you can guess, it was already minus 1. Minus 1 plus 4 is going to be a plus 3 on the end. Okay, sorry, I've messed up this. Let's go forward again. And the number of questions goes up the side. How long did Lucy take to answer the first 20 questions? So check on the side of the graph, 20 is here, was 20 questions, and so that was 10 minutes. At which times during the competition was she answering at the quickest rate? So that's always the steepest gradient, which is the first 20 minutes, where the gradient is the steepest. Hemi worked at a constant rate and answered 80 questions. Draw where the graph shows this. So he answered 80 questions in 60 minutes. Oh, Hemi worked at a constant rate and answered 80 minutes total. So he will be 50, 70, 80. So let's draw a yellow line for Hemi here. So using a ruler, and write the name on there. That's Hemi. Over the page, Maria arrived 20 minutes after the start. She answered 60 questions during the first 20 minutes she was there. So she only started at 20 minutes and she answered 60 questions. Let's give her blue. So she goes up to here. The last 20 minutes was half that rate, so she's only going to answer 30 questions, so she'll get something like that in the second. How many minutes from the start of the competition has Maria answered the same number of questions as Lucy? So that would be where you need to look at where they intersect. I think it would be here, which is about 33 minutes, where the two lines cross. And the last part of this, over the 60-minute competition, describe the times when each student answered more questions than the other two. So when you're looking at the graph, you must look and see which competitor is at the top line on the graph. So if I go back, okay, so we'll go to the page. The last question, give the equation of the graph. This graph is obviously, it's quite a narrow graph, and I know my intercept here is at 1 and here it's at -2. So my equation, you know how to do that. Y equals some number, and I must have x plus 2 and x minus 1 in the factorised form. Now, how do I find what a is? I must find a point on the graph which has an x and a y. So this point here I know is 0 across and 6 up. So let's put that in. I'm going to change this to a 0, and I'm going to change the y to 6. So if I do that, 6 equals a times 2 times -1. So 6 equals a times -2, divide by -2 on both sides. A equals -3. So the equation of my parabola must be y equals -3 x plus 2 x minus 1. Now if this is translated m units to the right, remember if we translate to the right in the brackets, we're going to do the opposite, so it's going to be a -1 in the brackets. So for each of these brackets I've got to add a -1. So my equation is going to be y equals -3. That'll be x plus 2 minus 1 is plus 1. And x minus 1 minus 1 is x minus 2. And, oh, it's only gone, it's gone m units to the right, not 1 unit to the right. So this would have to be minus m in each of those brackets. Let me just rub this out here. So this bracket will be x plus 2 minus m, and this bracket will be x minus 1 minus m, and it's gone n units up, so when we go up we just add it onto the end. So that will be the equation of my new translated parabola. Thank you.